Continuing our discussion of section 4.4, now we're going to start looking at some of the components or the characteristics of the sine and cosine graphs. First, we'll look at the amplitude of a graph, which is how tall the waves basically reach. If you're looking at either a sine or a cosine graph, they both have this same basic shape of a wavy pattern. So you can either think of the amplitude as half of the distance from the highest point down to the lowest point, cut that vertical distance in half, or you can say from whatever point is going through the middle of the graph, it's the distance from there to the top or the distance from there to the bottom. So the amplitude describes how tall the waves are in our graph. Next is the period. This one describes how long it takes for you to go through one complete cycle of the graph, and then there are several ways that you could pick a starting and ending point of this pattern. For example, sometimes one of the easiest things to do is pick one of the peak points at the top of the graph and then see how long it takes for you to go through following along the shape of it until you hit that point again at the top a second time. So that way it has completed one full cycle and it's just going to do that pattern again. That would be another period, and it's going to do that pattern again. It would be another period. So basically going through the entire pattern of the graph once is one period of the graph. You don't have to do it from the top though. Another common case is to pick where it's going through the midpoint, the middle of the graph, which usually happens at the line y equals 0. So if you pick that point, the only thing you have to be careful about is where it's hitting the middle of the graph, going from the trough up to the peak. So it's where the graph is increasing that it passes that line. The reason I'm stressing that is because when I hit this point right here, I am at the same height, but I'm not at the same point in the graph's pattern, because here I was going up, here I'm going down or decreasing. So I actually need to keep going until I hit that middle point again. So that would be another way of defining the horizontal period of the graph. What is the horizontal distance from one of those points to the other? The last thing I have listed on here is the frequency, which will not be as important for us. Basically, it just defines in a certain unit interval how many times does the graph go through that pattern before it hits that unit interval length. So mathematically, whether we're dealing with sine of x or cosine of x, we saw in the last section that there are several values that can affect the shape of the graph. There's what stretches the graph vertically, there's what stretches the graph horizontally, there's the shift horizontally, and then there's the shift vertically. Now, whether you're dealing with sine or cosine, if I say what is the amplitude of the function, you just need to take the number that's being multiplied by sine or cosine and take the absolute value of that number. The amplitude only cares about the positive value. It doesn't care about the negative, because that just means the graph has been flipped upside down. The amplitude's height is the same whether it's been flipped or not. Next, we have the period. For this value, you're going to be looking for a number multiplied by x, not the number being multiplied out front by the whole function, but the number being multiplied by x. It's always going to be 2 pi divided by the absolute value of that number. So again, ignore any sign changes on it because the signs just cause the graph to flip. We're just trying to define the length. So take the absolute value of the number being multiplied by x and put that underneath the 2 pi. Simplify if possible, of course. The frequency, which again is not going to be as important for us, this will just be the reciprocal of that value. So once you've found the period, just flip that fraction upside down and you'll have your frequency. It's unlikely you'll have to do any rationalizing or anything. If you already simplified and set up the period, then the frequency should be okay. And the last one is the phase shift. Now, what's a little tricky with sine and cosine graphs is that it's not just the c value that determines the horizontal shift. If there is also a b number in this position, then you actually have to do c divided by b to figure out how far the graph is shifting to the left or to the right. Now, it's not that common that you have a number in both spots. Usually, you only have something being added to x, in which case b is 1. So then when I say c over b, you just end up with c over 1, which is c. So usually this is the only number you have to look at for shifting the graph to the left or to the right, but technically if you do have a number here as well being multiplied by x, make sure you do c divided by b. And if that number is positive, so if you have a plus in between the x and the number over here, then the graph is actually going to be shifting to the left. And if it's a minus sign in here, so you actually have a negative number for C or a subtraction sign, then that's when the graph will be shifting to the right. And that's true for either sine or cosine. So here's the kind of thing you'll be doing in the examples. They will frequently ask you to define both the amplitude, period, and maybe the frequency as well, and then they'll give you the function over here. So describing the transformations, we'll come back to that. Again, that was what we were doing in the last section. So the first thing we have is the amplitude. Now for the amplitude, we said on the last slide that all you have to do is take the absolute value of the number out front that's being multiplied by the function, whether it's sine or cosine. So in this case, the number that is being multiplied out front is 1/2. Now this one's already positive, so the absolute value of 1/2 is just 1/2. So we have just described how tall the graph is going. If I sketched this out, then from the top to the bottom of the graph is a length of 1, because half of that is the amplitude. Next, we have the period. So how long does it take for the graph to complete its pattern, to go through a full cycle? The period is 2 pi divided by the absolute value of b. So we want to look at the number that's being multiplied by x, and we're going to do 2 pi divided by that number. Looking at our specific example, the number that's being multiplied by x is a 3. So I have 2 pi divided by the absolute value of that is still just 3. So this is how long it takes for the graph to go through one wave pattern. Last thing they want us to identify is the frequency. And that's just going to be the reciprocal of this value. So showing you that the period and the frequency are just reciprocals. So take our previous answer and flip it upside down. Now this one didn't ask us to identify the phase shift. They very well could have. The problem is, for the phase shift, I don't have a number that's being added or subtracted from x inside of the parentheses. So if that number is a 0, then you do not have a phase shift. The graph is not being moved to the left or to the right. There's no shift there. So that's why I don't have a phase shift listed on this one. If we were being asked to describe the transformations of the function, then the things you would want to comment on are that the graph is being compressed vertically. So it's cut in half for height for the normal sine graph. And then the second important thing is having the number being multiplied by x inside of the function is compressing the graph horizontally. So it's being compressed vertically, cut in half, and it's being compressed horizontally. It's a third as long as the graph usually is. We were doing some of the graphing trig function examples in the last section, but now I'm introducing a new phrase here. I'm saying I want you to graph 2 full periods of this function. So let's talk about what that would mean. First thing I like to do when I'm graphing these trig functions is draw in kind of the skeletal outline of where the regular cosine of x graph meets. So you'll want to keep practicing those. Cosine hits at the point 0, 1, and then it touches here and here, and then it just keeps bouncing up and down. So every time you hit one of those key values, pi over 2, pi, 3 pi over 2, 2 pi, etc., it goes between these patterns of hitting the top, bouncing down to the bottom, bouncing back up, etc. Now by having 2 times cosine of x, that would be doubling the height, and then we're also going to take that point and shift it down 1. So I'm taking my red dots, I'm multiplying them by 2, and then I'm subtracting 1. So a height of 1 times 2 minus 1 brings me right back here. Height of 0 times 2 minus 1. Negative 1 times 2 is negative 2, and then subtract 1 more. 0 times 2 minus 1, and a height of 1 times 2 minus 1. And so you can keep just following basically all of the dots that I had actually on the x-axis. All end up shifting down 1. All of the dots that started up above at a height of 1, those all end up coming right back to where they were originally. So I'm just looking at the pattern for what happened to the other dots at that height. And then the ones that started at a height of -1, those all ended up moving down 2 units. So any of the dots I see from before moved down 2 units. So now I can see what the end effect is of my shifted graph. Now, the reason I'm asking you for 2 full periods is because I'm trying to see a certain amount of the graph. I don't want to just see like one tiny little piece like this and have you say, yep, that's the graph of 2 cosine of x minus 1. I want to see at least 2 full cycles through the pattern. So oftentimes -2 pi to 2 pi is sufficient for this, but notice if we start here on the very far left dot that I drew, it's starting at the top of the graph, and then it's moving down, and then it bounces back up. And that's one period right there, because I went from the highest point of the graph, and I went all the way through one full cycle of the graph. And then I'm going to bounce down again, and then continue back up, and it lands from the peak of the graph to the peak of the graph. So that's another full period of this shape. If you wanted, though, you could have easily stretched it out more to the right. I'm just trying to see the entire pattern a couple times. You could have started from here at the middle height of the graph and then gone through it once, and then gone through it a second time off on the end if you would have rathered. So the point is just to make sure you have at least 2 full periods or 2 full cycles of the graph's pattern from no matter where you start on it. And usually I find that -2 pi to 2 pi is sufficient for that. So that's all for the notes today. Thank you guys.